Some of the most terrifying flood footage ever uploaded to the internet has just emerged from the mountains along the border between Nepal and Tibet. In the videos, an enormous brown wall advances through a narrow valley. Buildings vanish into it. Vehicles are carried away like leaves. Entire settlements are overwhelmed within seconds. The front of the surge rises so abruptly that it looks almost exactly like a tsunami. But this happened high in the Himalayas, hundreds of kilometers from the nearest ocean. And here is the part that has confused millions of people watching this footage. There was no massive rainstorm sitting over the valley. The river had not been slowly rising for hours. No warning sirens went off. The wall simply appeared. So what on earth actually caused it? Because the real answer is something far stranger and far more disturbing than a flash flood. The disaster struck on the morning of August 26, 2026, in the mountainous border region between Nepal's Rasuwa district and Tibet's Girong County. Within hours, images were circulating worldwide showing the Bote Koshi and Trishuli river systems carrying away roads, bridges, hydropower stations, and entire villages. The current confirmed death toll stands at over 270 people across both countries, with nearly 1,500 still missing, including hundreds of foreign tourists who had been traveling near the border. Those numbers are almost certainly going to rise as rescue teams reach areas that are still cut off. The first explanations offered by officials were the obvious ones. Some pointed to a glacial lake bursting. Others suggested an earthquake had triggered a landslide. And seismic instruments did in fact record something significant just before the flood arrived. The United States Geological Survey initially logged it as a magnitude 4.4 earthquake. But within hours, that interpretation completely fell apart. The USGS confirmed that the seismic waves had not come from a tectonic event at all. They had come from something collapsing, something enormous. And once scientists identified what that something was, the entire disaster started to make a very different kind of sense. Satellite images from Planet Labs, taken before and after the event, pinpointed the source high above the upper Lendekola Valley, about 20 kilometers, or roughly 12 miles, northeast of the Nepal-China border crossing at Rasuwagati. What the images revealed was a section of glacier and mountainside that had simply detached. A colossal mass of ice, fractured rock, and sediment broke away at approximately 5,200 meters of elevation. That is around 17,000 feet, well above the height of most European Alps. It then fell around 1,200 meters, or nearly 4,000 feet, down the mountain face. That is the height of the Empire State Building, 3 times over, falling all at once. At this stage, no river was needed for the collapse to become dangerous. When a mass of rock and ice this large fails on a slope this steep, it behaves like a granular fluid. The blocks collide, shatter, and spread out across the valley floor. But the entire mass continues moving under its own momentum. This is called a rock ice avalanche, and it is one of the most destructive phenomena on Earth. It also explains the seismic signal. The impact of that much material hitting the valley floor at high speed generates ground vibrations that look, on a distant instrument, almost identical to a shallow earthquake. That is why the initial classification was so wrong. The mountain itself was the earthquake. Here is where the story genuinely changes. Because a rock ice avalanche on its own does not usually travel 30 or 40 kilometers downstream. It runs out. It piles up. It stops. This one did not stop. The reason is a process called entrainment. And it is the single most important idea for understanding what those videos actually show. As the collapsing material raced down into the valley, it hit the Lendekola itself, along with the meltwater ponds, saturated sediment, and loose debris that already filled the floor of the valley. Instead of just sliding over the top of all of that, the moving mass scooped it up. It tore material out of the valley floor and absorbed it. Rock, mud, water, boulders, and shattered pieces of glacier all mixed together. And that mixture behaved completely differently from the original avalanche. It became something geologists call a debris flow, a fast-moving slurry that is roughly the consistency of wet concrete, but traveling at highway speeds and carrying boulders the size of cars. And this is the key point that most reporting has missed. The avalanche did not get diluted when it hit the river. It got bigger. It swallowed the river. Studies of comparable rock ice avalanches suggest that the water absorbed from the river and wet sediment can actually contribute more fluid to the flow than the melted glacier ice itself. So what you are watching in the footage is not a river overflowing its banks. It is a mountain that has progressively turned itself into a flood. If you have seen the footage, you have probably heard people call it a tsunami. It is easy to see why. The front of the surge is almost vertical. It bulldozes buildings. It moves with a kind of unstoppable weight that most floods simply do not have. But it is not a tsunami, and the distinction actually matters. A tsunami happens when something, an earthquake, a landslide, an underwater eruption, suddenly displaces a body of water. The water itself then carries the energy outward as a wave. If this glacier had fallen into a large lake, that could have produced what is called a landslide tsunami. Energy passing through water, with the water staying more or less where it is. That is not what happened here. In the lendecola, the mud, the boulders, the ice, and the water were all part of the flow. The entire mixture was traveling together. It was the material itself moving downstream, not a wave passing through it. The near vertical wall at the front is just a natural feature of large debris flows. The heaviest, coarsest material, the boulders and the rock, concentrates at the leading edge and forms a dense, mechanically powerful front. The wetter, muddier slurry behind it keeps pushing that front forward. It is essentially a bulldozer with a river behind it. There is also an ongoing scientific question about whether the avalanche briefly dammed the lendecola. In a narrow Himalayan valley, millions of tons of ice and rock can pile up and block a river for minutes or hours. Water then builds up behind it, until the natural dam gives way and releases in a single pulse. That would explain why one downstream monitoring station recorded the river rising by up to 9 meters, nearly 30 feet, in just 30 minutes. That specific sequence has not been confirmed yet, but it fits the pattern of similar events elsewhere in the Himalayas, and it fits the timing of the surge that people caught downstream. Preliminary timing suggests the glacier failed at approximately 8:37 in the morning local time. The river began rising catastrophically at around 9. The first border communities in the flood's path had, at most, a few minutes between the collapse itself and the arrival of the surge. And there is a very specific reason no one was warned. Modern flood warning systems in mountain regions are almost entirely built around measuring rainfall, monitoring upstream river gauges, and running weather forecasts. All of those are excellent tools for storm-driven floods. None of them predict the spontaneous collapse of a glacier on a clear morning, 20 kilometers upstream, in a remote valley on the opposite side of an international border. By the time downstream gauges detected the river rising, the debris flow had already reached them. Several of those monitoring stations were then destroyed by the same flow they were measuring. This is the darker lesson of what happened in the lendecola. The current generation of early warning infrastructure in the Himalayas was designed for the wrong kind of disaster. The threat is no longer just the monsoon, it is the mountain itself. Which brings us to the question everyone is quietly asking. Why did the glacier collapse in the first place? Satellite observations show that a significant amount of snow had disappeared from the source area during a warm period in the days before the disaster. That kind of rapid melt can allow meltwater to penetrate deep into fractures in the ice and rock, or to reach the base of the glacier itself, reducing the friction that was holding it in place. More broadly, glaciers throughout the Hindu Kush and Himalayas have been thinning for decades. The permafrost that acts like natural glue on high mountain slopes has been thawing. Rock walls that were frozen solid for thousands of years are becoming unstable. And this is not the first sign. In July of 2025, an outburst flood down this same Hundal River destroyed the Nepal-China Friendship Bridge at Rasuagati and killed more than a dozen people. That bridge had only recently been rebuilt. This month, the same river system did it again, bigger, faster, and with far more casualties. The International Center for Integrated Mountain Development has been warning for years that floods, landslides, and glacier collapses in the Hindu Kush Himalayas are increasing in both frequency and severity. What happened on August 26th is exactly the kind of event they said was coming. It is unlikely to be the last. A section of glacier and mountainside failed under its own weight. The resulting rock ice avalanche fell more than a kilometer. It struck the valley floor with enough force to register as an earthquake on instruments around the world. It entered the lendecola, absorbed the river and its sediment, and transformed into a fast-moving debris flow. That flow then surged through populated valleys tens of kilometers downstream, taking with it roads, bridges, homes, and lives. What the footage shows is not simply a flood. It is a mountain in the process of collapsing, and progressively turning itself into one. But behind the geology and the terrifying images is a profound human tragedy. The people caught in these valleys had almost no warning. They had no reason, on an ordinary morning, to expect that an entire mountainside was about to send a wall of debris towards them. Many lost their lives. Countless others lost their homes, their families, and their futures in an instant. As we try to understand how this disaster unfolded, we should also spare a thought for every person and community now living with what it left behind. Thanks for watching. And a big shout out to my Patreon and YouTube members. Thank you so much to everyone who helps support this channel.